Okay, most of this will be review for you, so if you feel like you know a lot of the vocabulary, just kind of fast forward through the video to see what you know and don't know. And if you don't know it, put a star by it so you know to look back at that when you're looking through your notes. Okay, triangles. This is a triangle, obviously. We know what a triangle is. It's going to have 3 vertices. Remember where the 2 segments come together at a point, that's a vertex. There's 3 of them. It has 3 angles. 1, 2, 3. And it has 3 sides. And the sides are segments. So AB, AC, and BC. You can name a triangle with any 3 points on the triangle in any order. So I can call this ABC, CBA, BCA, BAC, etc. Okay, so go ahead and pause the video and looking at this triangle here, name it, list the vertices. Remember, you have to use your proper notations when you name your angles and your sides. Press pause and I'll have the answers up for you in just a second. Alright, here's your answers. In order to be considered correct, you have to have the symbol here for triangle, you have to have the symbol here for angle, and you have to have the symbol here that tells us these are made up of segments. If you have a question about how to name a triangle or any of these here, raise your hand and let us know. Okay, opposites. When we're naming opposites, always highlight what we're referring to, and then kind of imagine if you throw a ball across from. That's what opposite means. It means across from. So the first one says, what angle is opposite XY? So here's XY. Let me go up a little bit. Here's XY. So place a little ping pong ball. We'll place a little ping pong ball on XY. And I want you to throw that ping pong ball. What angle would it fall into? Well, it falls into angle Z. So angle Z is opposite this side XY. All right, opposite YZ, here's YZ. Take your little ping pong ball, throw it, and see what corner pocket it lands into. That corner pocket, or that angle, is the one that is opposite your side. So that angle opposite YZ, or across from YZ, is angle X. All right, doing the same thing, let's see if you can figure out what angle is opposite XZ. Pause the video. And you should have gotten angle Y. Here's XZ. Across from XZ is angle Y. And you'll notice the pattern here. When I say opposite, it's not going to have either of these 2 letters. It's going to be the angle that doesn't share the letter X or Y. So whatever's left over is Z. Okay, let's talk about opposite sides. So imagine if you're given angle T, imagine that the angle is kind of like a gun or something, where you're going to shoot from that gun. Whatever you're ending up shooting, YR, is the side that is opposite that angle. So in other words, the side opposite the angle is going to be across from the angle. So side YR is opposite angle T. Trying again with the second one, which side is opposite angle R? So imagine angle R, shoot a ball, cross, and you get side TY. That's the side that you would hit. That's your opposite side. So go ahead and pause the video and tell me what side is opposite angle Y. And you should have gotten side TR. Here's angle Y. Across from that is side TR. Please make sure you're using the proper notation to list a side. Okay, a right triangle, the side opposite the right angle. So here's my right angle. Across from that, this side, ET, is called the hypotenuse. The 2 sides that form the other angles, so this side and this side that form angle T and angle E are called the legs. Okay, so go ahead and pause the video and answer these following questions for me. And you should have gotten the following answers. If you didn't and you don't understand why or how I got these answers, ET, hypotenuse, RT, and ER, and the legs, go ahead and raise your hand and let me know. All right, what I would like for you to do on this page is go ahead and just pause the video, see if you can answer or describe each of the following triangles. I know you guys have heard of these before. You do it every year in geometry or every year in math in middle school. So I know that you can come up with something. So pause the video and sit and think and see what you can come up with. All right, an acute triangle, all of the angles are less than 90. So you can look at this and see that they're all going to be less than 90. Obtuse, you're only going to have one angle that is greater than 90 degrees. I should change this to degrees. A right triangle is going to have one angle that is equal to 90 degrees. And an equiangular triangle is going to have all the angles being the same measure or congruent, and their measures are going to be 60 degrees each. That's how you classify a triangle, by their angles. So make sure if I ask you to classify that you know what I'm referring to. Classify by angles or classify by sides. Classifying by sides, we have a scalene. No two sides are congruent in a scalene, and you're going to know that you don't have any sides congruent because none of them will be marked congruent to each other. An isosceles triangle, you're going to have at least two sides that are congruent, and you know which sides are congruent, this one and this one, by the markings. In an equilateral triangle, you have all three sides congruent, and they'll be marked. One side, two side, three sides congruent. An isosceles has a bunch of different vocabulary words embedded in just this one triangle. In an isosceles triangle, the two congruent sides, so here AB and AC, are called the legs, just like the two sides in a right triangle that are adjacent to the right angle. The angle formed by the legs, so this one right here, so leg here, the one formed by it, this angle A, is called the vertex angle. The other two angles, down here and down here, are called the base angles. And the side opposite the vertex, so here's my vertex, A, opposite means across from, this side here, BC, is called the base. So the base angles, C and B, are touching the base. All right, pause the video and tell me what is the vertex, which sides are the legs, which side is the base, and which angles are the base angles. Make sure you're using your proper notation. Okay, check your answers. If you're not sure why you got something wrong, if you did, go ahead and let us know. Make sure you're using the proper notation for listing the sides. And I know I gave it to you this time, but make sure you put the angle symbol if it's asking for an angle. All right, we can extend the sides of a triangle. So if you take this triangle here and start extending the sides, so see how there's arrows here? If we extend the sides of a triangle, you have other angles that are formed. So when the sides of a triangle are extended, other angles are formed. The three original angles before we extended those sides, those are called the interior angles. So 2, 3, and 5. Interior means they're inside the triangle. The angles that are adjacent to the interior angles are called the exterior angles. So angle 6 is adjacent to angle 5, and angle 6 is the exterior angle. Angle 1 is also an exterior angle, and angle 4 is also an exterior angle. Each vertex is going to have a pair of exterior angles, but we only draw one. I could also draw it this way, and this way, but you're only going to see one in a picture because this gets too overwhelming. All right, go ahead and take a moment, pause your video, and list the interior angles and the exterior angles of this triangle. Alright, and you should have gotten 2, 3, and 5 for the interior, and 1, 4, and 6. Make sure you're using the angle symbol for the exterior. The Triangle Sum Theorem, just a fancy way of saying that the sum of the angles, the interior angles of a triangle, is 180 degrees. So if I add up angle A, B, and C, it's going to equal 180 degrees. So you're going to have to know this. So when you're given 3 angles of a triangle, to find the third angle, or any missing angles, or any missing variables, you add all 3 angles together, 41, and set them equal to 180 degrees. So x plus 28 and 41 is 69, equals 180 degrees. Subtract 69 from both sides. So x equals 111. Asks for the angle measures, so this angle measure is 111 degrees. I need to check that. How do I check it? Well, 111 plus 41 plus 28 should equal 180 degrees. And that's how I know I did it correctly. Okay, so you try example B, pause the video. Don't just find x, but you're going to have to plug x back in to tell me what this angle is. If you got x is 20 and then plugged it back in and got 59 degrees, go ahead and fast forward your video and try the next example. Otherwise, stick around and we'll work it out right now. The 3 interior angles of a triangle add together, so 3x minus 1 plus 31 plus 90, and they equal 180 degrees. I'm going to combine my like terms, negative 1, positive 31, and 90 gives me 120. So 3x plus 120 equals 180. I'm going to subtract 120 from both sides. So 3x equals 60. Divide by 3. So x is 20. To find my angle measure, I do this angle here, 3 times 20 minus 1, which is 60, minus 1, which is 59. Okay, go ahead and try letter C. The variable expressions represent the angle measures of a triangle. Find the measures of each angle. So you're going to have to draw a little picture so you understand that A, B, and C are just the angles in a triangle. And then after you find out what x is, plug that x back in to find the measure of the angles. Pause the video and let's see what you get. Oh, and also after you find the measures of each angle, you're going to classify the triangle by its angles. So equiangular, acute, obtuse, right, etc. Okay, you should have gotten that x is 33, angle A is 33 degrees, angle B is 66 degrees, angle C is 81 degrees, and because these are all less than 90 degrees, this is an acute triangle. If you don't understand how I got these answers, just go ahead and raise your hand and let me know, or ask a neighbor. Okay, the exterior angle theorem says that the measure of an exterior angle, so angle 1, of a triangle is equal to the sum, so that means adding together, of the 2 remote interior angles. Remote interior angles are the angles that are non-adjacent to the exterior, meaning they do not touch the exterior angle. Those are your remote interiors. So to see that as an example, using that theorem, find the value of x and then find the measure of the exterior angle. The 2 remote interior angle, x plus 72, have a sum equal to the exterior angle. So the 2 remote interior angle have a sum equal to the exterior angle. So solving for x, I'm going to add 11 to both sides. I get x plus 83 equals 2x. Subtract x from both sides, so I get x is 83. Finding the measure of the exterior angle, I have to plug that 83 back into this exterior angle 2x minus 11. That's going to give me 155 degrees. Okay, pause the video and see if you can do this next example. Okay, you should have gotten that x is 39, and the exterior angle, plugging that 39 into here, gives you 149 degrees. So what we do is we take the two remote interior angles, that means the one that's not touching the exterior, x plus 110, add them together because they equal the exterior angle. I'm going to add 7 to both sides, so I get x plus 117 equals 4x. Subtract x from both sides, so I get 117 equals 3x. Divide by 3 gives me x is 39. I have to plug that x back in here. 4 times 39 minus 7 is going to equal 149 degrees. Okay, another of many vocabulary words. A corollary to a theorem is a statement that can be easily proven using the theorem. Well, the Triangle Sum Theorem says that if you add all the angles of a triangle together, they equal 180 degrees. Well, if you have a right triangle and you take away that 90 degrees, what's left? 90 degrees. So 180 minus 90 is 90. So anytime you have a right triangle, what's left between the two acute angles of that right triangle is going to be 90 degrees. So the two acute angles of a right triangle are complementary. You guys know that word. Complementary has a sum of 90. So we can take a shortcut with example A, finding the angle measures. We can take a shortcut with this. Instead of taking all the angles, 3x plus 2 plus 31 plus 90 equal to 180, we can just take the two acute angles, 3x plus 2 and 31. Oops. There we go. 3x plus 2 and 31. And those two together are going to equal 90. So 3x plus 33 equals 90. So I subtract 33 from both sides. I'm going to get 3x equals 57. Divide by 3. So I get x is 19. Now, I found x. Didn't ask me for anything else, but it did ask me to find the angle measure. So I'm going to plug that x back in. 3 times 19 plus 2. That's going to be 59 degrees. And we want to make sure, does 59 plus 31 plus 90 equal 180? And yes, it does. All right, go ahead and start working on your practice worksheet.